Next up is our alkanes. Our alkanes are known to be saturated. We need to know the first 5 of them, be able to draw their structures, give a general formulae and describe their properties. Alkanes are the simplest of hydrocarbons and they are also known to be saturated. Saturated means that around each carbon is 4 single bonds, giving it a tetrahedral shape, as you can see here. Very simply, remember A, first letter of the alphabet, give it the number 1, and as a result of that, it's all the single bonds. The most simplest hydrocarbon is methane. Methane is the first alkane that you guys need to know, and its chemical formulae is CH4, and you can see its chemical structure to the right. Now, central carbon surrounded by all single bonds, then connected to hydrogens. After methane comes ethane, C2H6. The first thing you'll always do when you're drawing these is you put down the number of carbons first, check to make sure that you have an alkane, add in your single bond, and then around that add in the rest of your single bonds and attach your hydrogens. Please note, in an exam situation, if you do not have your hydrogens there, you will lose marks. Propane, C3H8, 3 carbons in a straight line. Add in your single bonds between the carbons. You then go back and add in your hydrogens around it. After prop becomes bute, 4 carbons in a row, single bonds, add in your hydrogens around it. Note that the terminal carbons, meaning the end carbons, should always have 3 hydrogens to make up the 4 bonds. Pent, meaning 5 carbons in a row, join in with your single bonds, then go back and add in your hydrogens. Now, there is a general formula that we use. Again, it's kind of like algebra, where n in this case means the number. So for example, if you have carbon 1, where n is 1, you do H 2 times 1 plus 2, which would give you your CH4. If you wanted to put in 8 there for octane, it would be C8, H 2 times 8, which is 16, plus 2 to give you your 18. If you remember that general formula and your prefixes, for example, meth, eth, prop, bute, pent, hex, hept, oct, non, and dec, you'll never go wrong. So, having a quick look at them, as you can see, the suffix or the ending is always "ane" when we're talking about the alkanes. And you can see there on the right hand side, every time you technically add a carbon, you're adding 2 more hydrogens to the previous one. For example, if you look at the difference between C7H16 and C8H18, you're adding 1 carbon and 2 hydrogens. Now, note at the end of that PowerPoint where it says decane, there is an error. It should have C10H22. When we draw them, we must be very, very aware that every carbon has to have 4 bonds in an alkane. All carbon atoms have to be connected in a chain, and the remaining bonds will go to the hydrogens around it. So what I'd like you to do is just go through these again and sketch them out, okay? So draw the structures. When we look at the properties of our alkanes, they're very interesting. The first 4 are gases, which means that they can be compressed, okay? And that's how we get our methane for our house gas. Our propane, I think we use that in the yellow colour gas bottles, and an awful lot of people use that for barbecuing. After the first 4, the following 12 are liquids. And then we would note that every time the chain increases, the boiling point increases. And the reason for this is you need a higher amount of energy to overcome the van der Waals forces between them, okay? So remember, you have two types. You have intermolecular bonding and intramolecular bonding. Van der Waals comes into the intermolecular bonding. So you need to be able to have enough energy to overcome the forces of van der Waals. Think about this for a minute. If you have a hydrocarbon, which we do, the likelihood of it dissolving in water is slim to none. Why? The hydrocarbon is non-polar, and we know like dissolves like. Water to polar, so it's not going to dissolve it. So we'd be thinking non-polar solvents such as hexane, etc. So that kind of brings us to the end of the alkanes. Ane, meaning one, single bonds all the time. Saturated compound means the carbon has 4 single bonds about it. Naming the first 5, meth, eth, prop, bute and pentane. Being able to draw the structures very simply. Start with your carbons, draw them in a line, okay? Add in your single bonds between them, then add in your bonds containing your hydrogens. The general formula is CnH2n plus 2, where n in this case is the number of carbons. And then talk about the properties. Very similar. In this case, remember your properties are they dissolve in non-polar substances, and as the carbon chain increases, the boiling point increases due to the fact that it needs to overcome the van der Waals forces between